In the early stages of the development of the branch of physics we now know as quantum mechanics, two German scientists, Albert Einstein and Erwin Schrödinger, engaged in a series of debates questioning its viability. While Schrödinger believed quantum mechanics was the future of physics, Einstein believed this theory was lacking, and both tried to use the same piece of evidence to prove their point: the possibility of quantum entanglement. In a nutshell, quantum entanglement is a sort of connection between particles. Two particles that are in a state of quantum entanglement, no matter how far apart, will respond accordingly to the changes in the other. What I mean by this is you cannot measure the properties of one without learning about the properties of another. Even across the span of several light years, the information travels instantly. But how can information travel faster than the speed of light? Einstein did not think it possible and believed this was the reason why quantum mechanics was not reasonable. Yet years and multiple experiments later, Einstein was proven wrong. We have found that quantum entanglement does exist, and we are able to wrap our heads around it, at least to some extent. But recently, experiments have been conducted which shatter our understanding of quantum entanglement. Until now, we have only attempted to understand the spatial implications of entanglement because we believed that was all that was possible. But temporal entanglement seems to exist as well. Scientists were able to entangle two photons which never existed simultaneously. They did this by first entangling two photons, which we have labeled 1 and 2. Then, they measured the polarization of photon 1, which would effectively kill it. This made photon 2 go absolutely nuts, while they created a new entangled pair of photons, 3 and 4. Next, photons 2 and 3 were measured in order to mirror the old entanglement relationships between previously entangled photons 1 and 2 and 3 and 4. This also destroys photons 2 and 3. Finally, photon 4 was the lone survivor, and they measured its polarization, which revealed that it was entangled with photon 1. What does this mean? Well, for one, we now know that entanglement is completely independent of space-time. This could mean that our theory that space-time is some sort of stage for the universe is completely false. What ideas do you have? Let us know in the comment section down below. We'd love to hear from you, and have a good day.